look at y equals 10 over x, we could find some values, okay? Kenzie, put that away, follow along, please. We can find some values. I could say, I insist, you have to draw this t-chart, you have to find some x's, or make up some x's, find some y's, and plot them, okay? That's not my desire for you. In my mind, that's takes up a bunch of time that's not necessary, okay? Unless I ask for specific, detailed graphs, and for the most part, I just want you to understand where this graph's going and what it's going to look like, okay? So if we look at numbers like 2 and 3, if I put 2 in there, what's 10 over 2? 5. So x is 2, y is 5. If I put 3 in there, then 10 over 3 is, what's 10 over 3? 3 and a third about, okay? And if I put 10 in there, what do I get? 1. So we had 5, 3 and a third, and 1. And so I get 10 would be like over here and up 1. Be there. So I get this. If I didn't miss my points, it looks something like that. Okay? Now if I look at the negative side of that, if I put negative 2 in there, what do I get? Negative 5. So negative 2 is negative 5. If I put negative 3 in there, what do I get? Negative 3 and a third. So it's like right in there. If I put negative 10 in there, what do I get? Negative 1. So 10 and negative 1. So I get this graph. Okay? So I have two branches to this inverse variation graph, don't I? I have one that's in the quadrant 1, where it's positive, and I have one where it's in quadrant 3, where they're both negative. Okay? So I have two branches. And that's what my graph looks like. Okay? Now, if I went and changed this to y equals negative 10 over x, what's that going to do to everything I found? It's going to flip it. So when x was positive, y is now going to be negative. And when x was negative, y is now going to be positive. And so when x is negative 2, y is a positive 5. When x is a negative 3, y is a positive 3 and a third. When x is negative 10, y is a positive 1. And so now I get a graph that looks like this. And we already talked about it, but when I flip my x's to positives, that's going to make my y's all negative. So if I'm positive 2, it's negative 5. Positive 3 is negative 3 and a third. Positive 10 is a negative 1. And so I get this graph. Okay? So we have, I put them both on the same one. I changed colors. You probably can't do that too well. So you have to realize or write in your note that these two branches come from this graph. And these two branches come from this graph.
So you want us to do the
Okay? You need to understand that when there's a negative here, when there's a negative here in the equation, it changes from quadrants 1 and 2, I'm sorry, from quadrants 1 and 3 to quadrants 2 and 4. Okay? And so we get the same numbers, but we get different quadrants. Okay? So if I can move on to the next page, let's get another graph. if I had this one? What's the difference between this equation and the last one? Yeah, the 2 instead of a 10, right? It's a smaller number up top. Right? And so if I plug a 2 in there, what do I get? A 1. Over 2 up 1. The other one was over 2 up 5, wasn't it? Okay? So the bigger that number, what's that mean about my origin? Further away from the origin my graph is going to be, right? So the smaller the number, the closer to the origin my graph's going to be. So this graph's going to look something like this. Okay? I really don't want you to take time after today to look at those individual little points and plot them and try to make it that accurate. I just want you to have a basic understanding that the bigger this number is, the further away from the origin the curve is going to be. Okay? And the smaller the number, the closer to the origin it's going to be. All right? And so if I have y equals, I'll do it in red again. If I have y equals a negative 2 over x, then I'm going to be graphing something like this. Okay? And so all I'm looking for when I check your graphs, are they in the right quadrants? Do they have a decent curve to them? And are you showing them attacking or I should say approaching the asymptotes correctly? Okay? In other words, don't let them cross over the asymptote. And then some of you still do things like this, and I still take points off. If you just go like this, it looks to me like you're starting to make some kind of a bad circle. And it's curling up away from the asymptote. It's curling back up here. It's curling back away from the asymptote. All right? And to me, that's just, I'm in a hurry, and I don't care, and this is where I'm at foot. I do want you to take some time. I just don't want you to take time to make a chart, find the values, and be very specific about where you put the points. I'm okay with your y equals 10 over x looking just like your y equals 2 over x, as long as you do a really nice job of drawing the curve and showing it approaching the asymptotes, and you have them in the correct quadrants. Okay? I'm okay with that. I do want you to understand, though, that the bigger that top number, the further away from those quadrants are going, or the further away from the origin you're going to be. Okay? So that is how we're going to attack the inverse variation. Now, yesterday I said to the question, will the inverse variation ever have a y-intercept? And I said no. Today we're talking about translations. Okay? And I think that may cause some confusion on what we're doing today. The model for our translations is y is equal to, I don't remember the letter, oh, k I guess they used, x minus h plus k. No. It can't both be k. I don't remember which letter they used there. Oh, they did use k there. It's the other one. C. Maybe that's not an H. I'm just used to the translation being an HK. Yeah, they use a B. Sorry. I'm used to our center being HK. Sorry, HK. And that's not going to be the case now. It's going to be BC. Okay? And the only reason they did that is because the k that we use as a constant, the variable to represent a constant, it was already in this model, and so they couldn't have a second k. That'd be confusing. So they just changed the other two to B and C. Okay? Quite honestly, I would have used a C. That's kind of what the word constant starts with anyway, right? And so I would have used a C here and then stuck with H and K, but they didn't, so let's move on with what they did. And so BC becomes our new origin. Okay? BC becomes our new origin. And these, if you understand that right there, that's all you have to understand. And you understand what we had already done on the other two graphs, then the rest of this is easy. It's look at it, draw the graph. Look at it, draw the graph. Okay? It is truly that easy. Let's get a new graph up here. Make a little more room. And let's write this. There we go. Let's choose this equation. We've already done 10, so let's stick at 10. 10 minus 3 plus 4. Okay? 10 minus 3 plus 4. So, 10 minus 3 plus 4, 10 over x minus 3 plus 4, I meant to say. What is my new origin going to be? Positive 3, positive 4. Okay, at first thought I heard, not at first thought, I did hear it. At first I heard some of you suggesting it's a negative 3 because that's negative. But then I'm hoping that what you saw instantly was that the model says that should be x minus b. So when b is negative, this would turn into an x minus a negative, which would make it x plus, right? So when this is a negative down here, then that makes that a positive b value. So if I go over 3 up 4, I get that point right there. That's the new origin. So this other graph, y equals 10 over x, is going to still be the same as this graph right here, except instead of being at the origin, the center of it, it's going to be at the point 3, 4. And so I'm going to draw, and you need to do this also. Draw dotted lines that represent your new x and y axis. Okay? So draw dotted lines that represent your new x, y axis. When you graph this, remember I said I'm pretty easy on what I want. I want it to be a smooth curve and be in the right quadrants, right? Well, now that we're translating, I want one more thing. I want you to draw the new x and y axis in, and now it's going to, what quadrants is this going to be in? What quadrants is this in? Is it positive? Yeah, so 1 and 3. And so when I graph that, it's going to go here and here. And so what is my let me try it again. What is my horizontal asymptote? That's what I meant to ask. What equation represents my horizontal asymptote? Okay, what equation? You gave me the right number, but how do I write it as the equation? Y equals 4. That's correct. And what is my vertical asymptote going to be?
Y equals 3.
X equals 3.
Shouldn't that be the other way around?
No. I know it feels crazy, but remember, everywhere on this line, the value of y is 4. And everywhere on this line, the value of x is 3. And so, I know the y-axis is vertical, and we're thinking vertical line should be y equals, but it's not that way. It's actually the other way around. Okay? Good question. All right, any questions on that?
I don't know if it's just because my graph is bigger. Mine hasn't touching on my bad as close.
Well, you just didn't draw it up there.
Would you mark it wrong?
Well, you should be a little closer. She's asking, she kind of did this. And asked if I would mark that wrong. Well, I do want you to understand that it's approaching this green dotted line up here. And if your graph's not approaching that line, I might have a little problem with it. Okay? So you should have it approaching that line. I don't care that you found that point right there and made sure it was right, and found that point right there and made sure it was right. I don't care about that. I just care that you're showing it's approaching these asymptotes, the vertical and the horizontal asymptotes, and that it's, but it's not going to touch it. Okay? So if you get really close to it and start to look horizontal to it, or parallel to it, I'm okay. But
So we have like a graph that's like 1,000 over X or something. Do you want us to draw it in a scale that would like make it so it looks?
you know,
like
that's a great question. He says, what if I had 1,000 over X? And obviously we're not going to plot the point 1,001, right? And so it would be good to change your scale to something else. Okay, and so I could call this, where was it, 100, 200, 300, 400. But again, I'm not super concerned about that, so if you just plot a couple numbers down there on your scale, I'm good. All right? I just want you to understand what's happening. All right? And that certainly shows that you understand. If you change your scale to big numbers like that, you're showing me that you understand that's really quite a ways away from it. Okay? So that's good. All right? Let me put one more up here. What if I have y equals 3 over x plus 1, we just stop there. Okay? If I have y equals 3 over x plus 1.
Would it be 1, 0?
negative ones, yeah.
So what you're asking me is this new origin, you're saying, right? Would the new origin be -1, 0? And I would agree with that completely. So if we and so the only dotted line I have to draw is this vertical one, where x, my new asymptote now, my new vertical asymptote is x equals -1. Now they may very well ask you to identify the asymptotes, and you can get that information directly from the equation. You don't have to solve anything, manipulate anything, you just have to understand what that means. And that means the whole graph is going to shift 1 unit to the left. Okay? And since there's nothing out here, I'm really adding a 0, so it's not going to shift up and down at all. It's still going to be on the x-axis, so the y asymptote, I'm sorry, the horizontal asymptote is still y equals 0. So when I graph this now, it's a positive 3 yet, so it's still going to be quadrants 1 and 3. And so it's going to look something like this. Okay? Now, let me add one little tidbit. This distance from here to there, and this distance from here to there, should be exactly the same. Okay? Now, I'm not asking you to make sure they're exactly the same. Just try to make them close to the same. Okay? Just try to make them close to the same. Now, if I drew this black line that I already have in quadrant 3, then in quadrant 1 I did this. Now that distance is definitely not the same as this distance here. Oops, sorry. This distance right here. And so I do want you to be just a little bit more careful in that respect. Yep. Okay? They don't have to be perfect, just make them pretty close. Alright? So what you could do is you could draw your first one. Say I drew this one. Okay? And then I get that point right there. And then just kind of go that same distance over and put a point there and try as you're going through to hit that point. Okay? Is that confusing to anybody? Mind your ways that? Alright. I don't want to take up a bunch of your time. I truly think it's going to be that easy. Write these numbers down. I'm going to tell you what I want you to do for homework.
And then after you put on
Yep, I will. We'll do 3 through 24 by 3s. And 41 to 45 odds. So that was 3 to 24 by 3s. And 41 through 45 odds. So not too many problems there, only about 11 problems.